Okay, everybody. So 14.2, we're still talking about trig functions. Let me get to the right page. So 14.1 was all about just graphing trig functions. And 14.2 starts the trig identities, okay? Now we've already learned one of the trig identities. Okay, and an identity is just when something equals something else, right? And we learned one, that tangent of any angle is equal to what over what? Sine of that angle over cosine of that angle. Okay? So that's one of the main trig identities. Okay? And the rest of them come from they're called the Pythagorean identities, and I'll show you why. Okay? So let's say that you have a right triangle. We're going to call this A, this B, this C, and this is some angle theta. Okay? Well, what do we know from this triangle? We know that A squared plus B squared equals C squared, right? From the Pythagorean theorem. We know that sine of theta is equal to what? B over C. What is cosine of theta equal to? A over C. And tangent of theta would be B over A, right? Okay. So the first trig identity we're going to look at is, what is sine squared theta plus cosine squared theta? Now, when you see sine squared theta, there's a reason they write it this way and not this way. Okay? This means you take sine of theta and you square it. This means you square theta and then take the sine of it. Right? So, what I usually do is when you see it written this way, you can rewrite it as this. Okay? Those mean the exact same thing. So then this, right? Okay, well, what is sine of theta squared? In any triangle, that would be B over C squared, right? Plus, what is cosine theta? It is A over C squared, right? So then that becomes B squared over C squared plus A squared over C squared, right? Well, they already have a common denominator of C squared. What's the top? B squared plus A squared. Well, since it's a right triangle, what is B squared plus A squared? It equals C squared. Okay? So no matter what your angle is, sine squared plus cosine squared of that angle is always 1. Okay? So that's your first trig identity. Sine squared plus cosine squared equals 1. All right? What now? That was a proof of that, yes. Okay? Now, there are two other ones. Now, there are two schools of thought here. I'm kind of the thought of, if you can learn one way that works for all of them, Let's learn that, okay? There are other people that say, well, if you can learn one way that's easier for these set of problems and one way that's easier for these set of problems and one way, then learn all three of them and learn how to tell when to use which one, okay? So if you're one of those people, I will indulge you and teach you these other two. If you're not, sine squared plus cosine squared equals 1 works for every problem, okay? If you change all your trig terms into sines and cosines, which you can do, because secant you could write as 1 over cosine. Cosecant you can write as 1 over sine. Cotangent you could write as cosine over sine. Tangent you can write as sine over. So you can translate everything into sines and cosines if you want to. And then the only identity you'll ever need to simplify is sine squared plus cosine squared equals 1. Okay? But there are two other identities that you can learn. And they are and okay? And so I'm going to prove these two identities, and that's going to be part of our exercise. So let's prove. I'll prove this one, and then the proof of this one is actually in your book, and it's very similar, but I'll prove this one, okay? So let's say I ask you to prove that tangent squared theta plus 1 is equal to secant squared theta. Okay? Well, tangent squared is sine theta over cosine theta squared plus 1, right? And so that becomes sine theta squared over cosine theta squared plus 1. Now, how could we add these two if we got a common denominator, right? Well, the common denominator would be cosine theta squared. How could we write 1 as something over cosine theta squared? What would it be? It would be cosine theta squared over cosine theta squared, right? So the common denominator is cosine squared theta. What's on the top? Sine squared theta plus cosine squared theta, right? And we just proved that that equals what? 1 over cosine squared theta, which is secant squared theta. Make sense? Okay? Because 1 over cosine is secant, so you got 1 over cosine times 1 over cosine, so that'd be secant times secant, which is secant squared. Okay? So here are your other two identities you can use when simplifying. Okay? So let me show you some ways you can do this. All right, so let's say I told you to find cosecant of angle beta if cotangent of beta equals 4 over 5 and 180, beta is between 180 and 270. Okay, now there are two ways to do this problem. One is what you learned last chapter, okay? And then one is using the new identities, okay? Last chapter, what you would have done is said, okay, cotangent is adjacent over opposite, right? Because tangent's opposite over adjacent. If it's between 180 and 270, it's here, right? Cotangent would be adjacent. So here's your angle. Adjacent over opposite, right? And then you could use Pythagorean theorem to figure out C. So 4 squared plus 5 squared equals C squared. So that is 16 plus 25 is C squared. So that's 41. So C would be the square root of 41. So then cosecant of beta is the reciprocal of sine, right? Sine is opposite over hypotenuse, so cosecant would be hypotenuse over opposite, right? So this would be plus or minus the square root of 41 over 5. Well, is cosecant positive or negative here? Tangent and cotangent are the only thing that's positive, so this would be negative square root of 41 over 5. Okay, that's how you knew to do it before. Well, now you can use the identity that has cotangent in it. Cotangent squared beta plus 1 has to equal cosecant squared beta, right? So that means 4/5 squared plus 1 is cosecant squared beta, right? So that is 16 over 25 plus 1 is cosecant squared beta. Well, that's 25 over 25. So if you add those, you get 41 over 25 is cosecant squared beta. If you square root both sides, you've got cosecant beta is plus or minus the square root of 41 over 5. Then you just have to decide if it's positive or negative. It's in the third quadrant, so it's negative. Get the same answer. Okay? I personally don't mind which one you use. Okay? In the next section that we're going to cover, you have to use the identities because you can't draw a triangle if you don't know what quadrant it's in. Okay? If you know what quadrant it's in, then you can draw the triangle or do the identity. I don't mind. But if you don't know which quadrant to draw it in, you can't do the triangle because you don't know what the angle would be. Does that make sense? You have to use the identities if it's in an unknown quadrant. But if it's in a known quadrant, I personally don't mind which either one you use. You'll get the exact same answer. Okay? So tonight's homework, actually, you could have done tonight's homework entirely before I taught you this section. So, because you could, it tells you which quadrant they're in. And so you could have just drawn a triangle and done it that way. I would encourage you to do it the other way because we're about to get to a section where that's the only way you can do it. Okay? So let me do a couple more examples. Yes. All right. So let's say that I ask you if cotangent of A equals 4, and A is between 0 and 90 degrees, find sine of A. Okay? So now there's two ways you can do this one. You know which quadrant it's in, right? So you could draw a triangle, make cotangent equal to 4. So cotangent is adjacent over opposite, so you could do 4 over 1. Pythagorean theorem would give you the hypotenuse. You could find sine of A really quickly. Okay? I'm going to do it the other way. So the only identity we have with cotangent is cotangent squared A plus 1 equals cosecant squared A. Right? So this becomes 4 squared plus 1 equals, I'm going to write this as cosecant A squared. To me, it's easier to work if you see it that way. Okay, so that is 16 plus 1 is cosecant A squared. So 17 is cosecant A squared, right? If you square root both sides, that means cosecant A is plus or minus the square root of 17. Is it positive or negative? Why? First quadrant, and everything's positive in the first quadrant. Okay? So then, if cosecant of A is that, what is sine of A? 1 over that. And then all you got to do is rationalize the denominator. And you get square root of 17 over 17. Make sense? All right. Let's do another one. Okay. If this were, instead of cosine x, if this just said instead 1 over 1 plus A plus 1 over 1 minus A, how could you simplify it? Get a common denominator, right? And you have to think of these as that's the whole term, right? That's the whole factor. So what would the common denominator be? Multiply them together, which is 1 plus cosine times 1 minus cosine, right? So to get that, what do we need to multiply top and bottom one of this one by? Right, so what we have is 1 over 1 plus cosine times 1 minus cosine x over 1 minus cosine x, right? Plus, what do we have to multiply top and bottom by here? 1 plus cosine. So we've got 1 over 1 minus cosine x times 1 plus cosine x over 1 plus cosine x. Okay, so the common denominator then is 1 plus cosine x, 1 minus cosine x. 1 times 1 minus cosine x is 1 minus cosine x, right? Plus 1 times 1 plus cosine x is 1 plus cosine x. So on the top, what do we have? 2. 1 plus 1. Right? On the bottom, we need to FOIL. 1 times 1 is 1. 1 times minus cosine x is minus cosine x. Plus cosine x times 1 is plus cosine x. And plus cosine x times minus cosine x is minus cosine squared x. Right? So that becomes 2 over 1 minus cosine squared x. Well, look at your three identities. Is there something that equals 1 minus cosine squared x? We know that sine squared x plus cosine squared x equals 1. So if you subtracted cosine squared x, you would get sine squared x equals 1 minus cosine squared x. So you could write this as 2 over sine squared x. Do you agree that that's 2 times 1 over sine squared x? And 1 over sine squared x is cosecant squared x. So you actually just proved your own identity. Which is crazy to me. No matter what angle you choose for x, 1 over 1 plus cosine plus 1 over 1 minus cosine is the same as 2 cosecant squared. No matter what angle you choose. Okay? But that's how you simplify. This would have been the original problem. This is the answer. Okay? All right. Now let me give you just one kind of intro into where this is going. All right? Because your homework really kind of stops short of where this is going. But let me do one more example. Okay? And then I'm going to show you one from next section. So let's say I ask you to simplify Okay. Like I said, I'm a big fan of trying to find one way that always works. And if you get stuck, one way that always works is to change everything to sines and cosines. Because that way you don't have to remember, do I need to use the cotangent formula or do I need to use the secant formula? Should I try to get it into secants and see if that works? If you do everything in sines and cosines, then the only formula you can use is sine squared plus cosine squared equals 1. Okay? So, if we get everything into sines and cosines, what is tangent? That would be, it's tangent squared, so that would be sine squared theta over cosine squared theta, right? Minus, this one is already in sine, over, we've got sine squared theta over cosine squared theta times sine squared theta. Right? Okay. Now this is a compound fraction. How can we simplify a compound fraction? Right? So, we're going to multiply top and bottom by cosine squared theta. On the top, what do we have? we have those cancel, so we have sine squared theta minus sine squared theta cosine squared theta, right? Over, on the bottom, we just have sine squared theta times sine squared theta, so sine to the fourth theta. Did I lose everybody? Are we good? Because that's over 1, so that those would cancel, and you just have sine squared times sine squared. Or you could have simplified this before. This would be sine to the fourth over cosine squared. So if you multiply that by cosine squared, it would just be sine to the fourth. Okay? I knew if I said it a different way, it would pick up a few each time. All right? So on the top, we could factor out a sine squared, right? If you factor out a sine squared theta, what do you have? You have 1 minus cosine squared theta. Right? Because sine squared times 1 would be sine squared times cosine squared is that. Well, what is 1 minus cosine squared? Sine squared. Because sine squared plus cosine squared is 1. So that is sine squared theta times sine squared theta over sine fourth theta. Well, what's sine squared times sine squared? That's sine fourth theta over sine fourth theta. Which is crazy. No matter what angle you pick, tangent squared minus sine squared over tangent squared times sine squared is always equal to 1. And you could test that out. You could pick some random angle in your calculator, do tangent of that, square it, minus sine of that, square it, over tangent squared times sine squared, and you would get 1 every time. Okay? All right. So what the next section is going to be verifying trig identities, okay? The only identities you have right now are, we know the reciprocal identities. So we know that sine of x is 1 over cosecant of x, right? We know that cosine x is 1 over secant of x. And we know that tangent x is 1 over cotangent x. Now you could also write that reverse. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent, right? Then we also know that tangent x is sine x over cosine x, which follows that cotangent x is cosine x over sine x, right? Then we got the 3 that we learned today, which the first one is the most important. Sine squared x plus cosine squared x equals 1. Then we've got tangent squared x plus 1 is secant squared x. And cotangent squared x plus 1 is cosecant squared x. So these are the identities you know, and these are the ones you can use to prove other things. Okay? Every problem that you're going to have in the next 2 sections can be done using these identities right here. Okay? So what it's going to look like in the next section, instead of saying simplify, it will say prove okay? So what this section would have said is simplify that. And you would have had to come up with this. Now it's just going to say prove this. And the thing that's frustrating is when you're proving, you can only work on the left side. You've got to work on this side until it looks like that. So you can't work it like an equation where you could multiply the whole thing by something and get rid of the denominators. Or subtract something from both sides. You can't do that. You can only work on this side until it looks like that one. Yes?
So we're really just simplifying the left side?
Yes, but it's not always that simple. So for this one, it's going to be, and I'm going to stop there, but Monday I'll show you what to do when simplifying this one doesn't lead to that, okay? And I've got a really good method of what to do when it doesn't do that. So I'll teach that on Monday. But I'm just going to show, because this one does do that. So using what we had, I'm sorry? Sines and cosines is what I would do, yeah. So tangent we could write as sine x over cosine x, right? Over 1 plus sine x over cosine x. And what we have is a complex fraction, or compound fraction. How can we simplify a compound fraction? So we're going to multiply top and bottom by cosine x. What's this times this? Sine of x, right? Cosine x times 1 is cosine x. Plus, what's cosine x times sine over cosine? And we're done. Okay? Well, they're not all that easy, but you're really, at least in the beginning, doing exactly what Justin said. You're just going to be simplifying the left side till it looks like the right one. Where that falls short is sometimes the right side is more complex than the left one was. So you can't simplify and get something more complex. So that's where you've got to have another way to do it. Okay? All right, so I'm giving you a 14.2 worksheet. Like I said, it can be done using methods from last chapter. But let's try to do it with using these trig identities, along with that. That's going to tell you if your answer is positive or negative. But you can use these to figure out what the answer is, then use this to figure out if it's positive or negative. They'll tell you which quadrant the answers are in. Okay? Which, like I said, using methods from before, that means you could just draw the triangle. But let's try to do it without, because next section, that's not an option. Okay? All right, let me stop this video. What's today? 7th. And I'll post this for y'all too. I mean, you can look at it